I'm Frank Bruckners. I'm a PE in Cisco, and I shepherd this particular effort. Couple of steps back. We started at the edge. We didn't really call it edge. We called it on-prem, right? Until 2010, everything was on-prem. And then the cloud came along, and we started to shift all the workloads to the cloud. And since 2015, we see the pendulum kind of swing back again, and that's for a variety of reasons. A couple of people found out that the cloud is not for free. They also found that there is bandwidth limits between you and the cloud, and it takes time and latency and whatever. Well, we see this pendulum swing back. One is cost, performance, latency, obvious. Another one is regulatory, right? Security, regulatory. You have to go and run on the edge. Because you must not run in the cloud, and I'm German, and GDPR is all over us, big time. Public sector, ooh, well, any cloud service you can't do. You got to go and run it yourself. Okay, and then the biggest thing that we see right now is there is loads of data and even more data generated, and people have the capacity to now do that and digest that data using AI. So 3 years ago, edge and AI, no real conversation. These days, 50% of all conversations that we're having are edge and AI. And it's probably going to be 100% anytime soon. So once this thing comes back and swings back, we love the cloud. Can we go and preserve that experience from the cloud while going back to the edge? That's what we want. So maybe you can go and try. So what does it take to do that? Well, what is in there? It needs to be easy as the cloud, abstracting away the complexities that we aforementioned. It should be fast, so go and deploy at the edge in seconds or minutes, as opposed to you send a man in the van and then you wait a couple of months and you have it. But let's keep the familiarity. So please don't give me yet another tool chain for running at the edge. And you know that this company that I work for is famous for giving you a highly optimized tool chain that just works for a Cisco router. It's awesome. It's good for you as long as you run on a Cisco router. Maybe you're not running on a Cisco router. Sorry. Edge. You should have asked the question by now, which edge? Right-hand side, Linux taxonomy, right? Centralized data centers. Left-hand side, very constrained device edges, so the typical sensors. And there is a range in between. And so you can approach this thing, edge, two ways. You can approach it like the hyperscalers do that, and Gartner calls that cloud out. I think it's a useful term, whether you like Gartner or not. Because they say, well, the cloud extends to the edge, and I just treat the edge as an extension of the cloud. And I just assume that it's homogeneous enough. I can use my DevOps operating model. It's still resource-rich enough. So bandwidth's not really constrained. Computer's not really constrained. So let's go and scale that up. But this only works up to a certain level. And we'll figure out what that level is. If you start from here, your concerns are quite different. It's all about location, because the sensor depends on where it is. It's very heterogeneous. And you're typically not dealing with a DevOps-style operating model, but you're dealing with people that are skilled in the art. Their art is not IT. They're doing something else. They might be a store manager of McDonald's. And yeah, they can flip a power switch, but that's it. And it's resource-constrained devices, very small devices, and the connectivity is constrained. So and where's this tripping point and where this concept doesn't really work anymore? And what we found with loads of customer conversations that we had over the past year and a half is the smart device edge, so small user-facing computers, where things kind of trip over, where things really change from an architecture perspective, where I can't really treat the edge as an extension of the cloud anymore. And what is this? This is deploy compute in as many locations as there are. Favorite coffee shop? Say Starbucks. It's 40,000.
Sure, yeah.
It's 42,000, right? Or Pete's, or McDonald's quick service restaurants, or it's your favorite retailer, or it's even if you think of automotive, shop floor, loads of locations worldwide. You need to go and roll out there. And all of these locations are typically not super well connected. They're very diverse, and they're still, in a way, like you need to go and manage them as a fleet. So I think this is the sweet spot where also these guys, they offer devices that are like $1,000 US a month. Here, we're talking about $500 ASP, right? So very small devices, and also like devices that are almost disposable.
Meraki.
You're scaling with a device.
Meraki.
Yeah, well, yeah, why not, right? Could be anything. So if we go from cloud native to edge native, what do we need to go and look into? I think for me, it's going a little back in history and founding it on something that we all know and that's been stable since then. So Adam Wiggins and the Heroku guys came up in 2011 with the 12 factors, and they're still there. And cloud native is still based on these principles. So how about we look at them and tweak them a little? So this is the 12 factors. So the separation of data and code, still there. Keep processes stateless, still there. But as we're looking at some of these things, there is no notion of location in there. There is no notion of this massive fan out in there, and that's what we have to factor in. There's no notion of bandwidth constraints in there. So the constraints that we're dealing with at the edge are not factored in. So what I'm suggesting is we slightly rethink these factors and look at what does it take if we're putting the constraints of the edge into the 12 factors. And let me go and highlight a few of those with a little bit more detail because it's all about location. Some of that is also about bandwidth constraints. So logging, obvious, like move from logs to metrics because metrics are more lightweight. Stream them, still, check. So first one is concurrency and scale. Historically, old picture, it really looks like 2011, right? It might look even like 1990. So you're scaling with the number of processes and you have workloads all across. And yeah, you run on a couple of compute devices, but you scale with the number of processes that you need in order to achieve, well, the capacity that you have there. That's historic. Now, if I'm running the same thing, not in one location, but I need to go and run this across 42,000 locations, I also have to go and consider what does it take to go and allow me to scale from another dimension, which is location. We call that sites per individual location. And as we're scaling them, we call these sites as a grouping of physical little compute nodes so that you can scale within a site with these little entities that are almost disposable. And then you have this factor of scaling the number of sites. And you might want to roll out an app with a single click to thousands of them. And we're deploying an app to a site, not to a particular node, because these little nodes, they can fail, they can be disposable, somebody can switch them off, they might go offline. Don't worry about those. Talked about disposability. Even sites are disposable in that we don't really go and craft state that we maintain at a particular state for a particular state centrally. So all I do is like, I can use this overused term, it's like borderless, it's intent. I would call that declared state or desired state. I put the desired state into the cloud and sites will fetch that desired state and realize it locally. So whenever something trips over, I reinstantiate the desired state. That works well with even a McDonald's store manager. Look at when these point of sale terminals fail today, you know what they do, right?
Yeah.
They rush to the terminal, they open the door, and hopefully Windows comes up. If it doesn't come up, again. And eventually you hit factory reset. And then, well, if that doesn't work, you basically replace. That's exactly the operational model that we're going after. So don't assume that there's anybody well-versed with debugging the thing and IT capable. The other thing that we can't assume is if you rely on services, like, yeah, the old model was like you have dependencies, obviously well declared. You want to declare the dependencies. And you have, well, you declare the dependencies, but these dependencies are across links that are like what you have in a McDonald's environment or in a Starbucks environment. That might be DSL links, that might be over whatever, wireless. So we can assume that we can reach the site, from a site, we can reach the cloud. Check, right? I think we agreed on that. The reverse direction, I'm not taking as a given.
Right.
Especially if the further we go out, the number of NAT traversals that we have to go and deal with is growing, for sure. And each of these little NAT devices behaves differently, as we all learn, which is why we all love the thing that we don't rely on, tunnels. Don't tell me like, I need a tunnel from the cloud to the site in order to operate it. we found that that's a non-value proposition for the people. And typically, I think you have something like even 1% of the sites down. Not all the sites, not the same sites, but some site. So what I can go and do is fetch state from the cloud, and I can push metrics to the cloud. That's what I'm assuming. Anything else I don't do from an operational perspective. So taken these principles, and then there's more stuff, like when you look at logs, as I said, there is, like, if you declare dependencies, as part of the dependency, you also want to go and declare the policy for that dependency, so that it can go, maybe even at coding time, put a link in so that later on, policy enforcement becomes more of a piece of cake. So that I have a hook that I can apply policy to, instead of like, I need to go and figure out with an ACL, what is this dependency and what policy do I link to that particular ACL? I don't want that. So if I deploy Edge Native, and I deploy this to our, well, most hated or most darling cloud native thing of the day, it's Kubernetes. If we look at Kubernetes oversimplified, because I'm trying to reuse the same architecture in this Edge Native context. Oversimplified, you have something that inputs intent into a database over an API, right, at CD. And then you have these workers, as cattle, fetch the state from the database and instantiate it. And the whole thing is treated as a pad, right? So I operate clusters and I take care of the clusters. If I apply massive scale out location to the thing, I can use the same logic principles. I need an API, a globally hosted API somewhere in the cloud that allows me to insert state into a database that hopefully scales, because I need this state to go and serve many, many sites. And these sites are all like cookie cutter. They're starting to be now kettle. Instead of having a cluster, one cluster, you have thousands of clusters. So it ends up being a cluster of cluster scheme without explicit dependency management. Make sense? Like, we got just zoom out one step, and we can use the same good old principles from Kubernetes, but at the same time, we still have horizontal, like, process level scaling here. We can still use, you need more compute, you need to shovel more of my little compute elements that might fail at any point in time. And then, well, I need to go and apply my earlier principle, like, need something that operates my edge, and I call that edge operator here, which fetches state from the database, hopefully it's sharded, and it pushes state, the metrics, up. No tunnels, no nothing. If these things go offline for a day, that's their problem. They will fetch the state whenever they come online and then realize the state locally. So it's not that everybody is consistently running the same software, but it's running the software that they can.
So, what about machines that don't come up? What about ones that stay on forever and ever and ever and ever?
That's their problem, right? You can't do anything about that.
Yeah.
So the one thing is that it might well be that the store manager is then the store manager of a McDonald's on a super tanker. Mm-hmm. And it's not connected, right? So you might only connect at the next hopper. Yeah. But then he'll only get the latest software when he's connected to the next hopper. So until then, you're listening to old music or whatever. So it could well be. But that, I think, is as best as I can. Mm-hmm. And I can't do any better. Instead of like, yeah, I could go and send a drone, or we're not doing that right now.
Best as I can networking. I like
it. And we build a system around that, and it's like, it's emerging, and I'm the emerging guy. So it's kind of there. We're lifting the covers a little bit, so you can start to play around with this. And we call this animal. It's still cloud native, right? It needs to be an animal. We call it Great Bear, and it's a cute little Great Bear with legs all the way to the edges. And let me go and show you an example. Like, I want to go and roll out a new site and deploy an app on that site. What I do with Great Bear. So back on the principles, we have applications, apps. We deploy these apps onto sites, and these sites are groups of nodes. So app nodes, these are little small computers. Small computers as little as this. So we build demos and stuff around, like, even Raspberry Pis. And so this is Raspberry Pi booted up with an OS and running a Great Bear agent. So you can bootstrap things even on, say, vanilla Ubuntu today. Key thing is we need a serial number to go and associate that, claim that device, much like, you know, the claiming procedure in Meraki. So we want to go and define a site, add a node, and then deploy an app. So first thing is we look at our dashboard, and the demo setup that we have is a site in London, one in Paris, one in Rolle, Switzerland, that's kind of the office in Geneva. Then we have 2 sites in Hungary, a sales office and the former Banzai office. A couple of people that work on the project came from the Banzai acquisition. And then if you zoom out a little, there is nothing in Cologne, and I live in Cologne, Germany. So what we're going to go do is now create a site in Cologne, my little home office. It's my home office. And yeah, I'm now giving you the opportunity to go and send me a postcard. I live in Gutenbergstraße 26, and that is the zip code.
Totally remember that.
Yeah, well, it's recorded, so we can go back.
Oh, this is going to be great.
Hate mail, right? So I'm back up. I have my office up in there. And next thing is, well, I need to go and run an app there. But before I do that, let's see. We need to go and register the node, right? And this is where our serial number comes in. So we need to go and claim this node. It's been booted up. It's been polling the thing and saying, well, I need an associated with the site. We put our serial number in. Then I say, well, this is my Cologne node. Now I claim the node, the marquee claim procedure, and I click apply, and it doesn't take too long until the check-in is happening, like going from red to green. So we're there. So we're ready to go, and it is the first node, so you see it's been bootstrapped as the leader. So the cluster is really autonomously managed, and it figures that out. Let's deploy an app. We go to our app store. We don't have too many apps right now, but we have things like an MQTT broker at the edge to make MQTT conversation reliable from a Meraki camera. 1,000 ICE agents. I've even seen that mentioned by Mark earlier on. Loads of people said, hey, can I go to apply that side by side? We have a distributed AI runtime there, but something that I'm using here is poor man's digital signage. We call that EDD. It's just allowing you to render content, video, or web data at a multitude of locations, like as many as, well, 40,000 or 100,000. Click there, say deploy, and then I'm just choosing where I want to go and deploy the thing. Here I'm just deploying that to my home office in Cologne. Need to go and parameterize that briefly. There's a control panel that I need to use for that in the cloud, and I need to go and put a token for authentication, and then I click deploy, and that what it does right now is just puts the intent into the database, and the node will check in with the database and realize that intent, and it's there. So we can go and deploy fairly quickly. So we have that up now. If I hover over this thing again, then I'll find out that the thing is now green. I have a deployment count, and I can even click on the thing and get more details. The details are mostly interesting to us, I have to say, like site ID and deployment ID. You don't care. As I said, it's still evolving. Now, what did we deploy? As I said, it's poor man's digital signage. So you give the guy a link, and then that link will be rendered at 1 to 100 locations. So high-level concept, what we show here is, let's render it at 3 locations, because that's as much as it can fit on a screen: Budapest, Cologne, Rolle. And I have this EDD thing deployed here, as you say. And so I'm going to go say which locations, what content. In this case, like, interesting example, I'm rendering Cisco.com. So I'm telling these things, okay, Cisco.com, then these guys will reach out to Cisco or the web and render it locally. So showing you the example, left-hand side, dashboard, right-hand side, 2 VNC connections that I had from my home office into Switzerland and Budapest, and this is my home office. You're looking over my shoulder. We put in the content. We say, well, roll this out to these sites, and the ugly IDs are still there. And then I click go, update content. Puts the state up, says, and these guys fetch the state. And then you see my home office, watch this thing, update first. And then Budapest updates, and then second later, Rolle updates. So yeah, it's poor man's digital signage. It's already quite helpful. We've built demos with content providers for digital signage, and all they hand us is a URL, right? And then we render this thing. So somebody else creates the beautiful content. What this just shows is it's very easy to roll something out to many sites, and it's a service that goes on top of the base orchestration infrastructure that we're building. Because what we found is without the services, a platform is not so useful. So we've built a bunch of services in multiple areas. So services and deployment, what services are useful? Like, we've looked at this fast deployment, but also needs to be like familiar, easy. Let's look at a little bit of that. So we looked at multitude of use cases, and yeah, render data. Most of the people have this need to it. Needs to have something where I can go and show a result on a local screen. That is next to an assembly line. It's if you are showing something in your favorite coffee shop. That's one aspect. The other thing is that what we always see is something data management, which is why you've seen an MQTT broker, and we're looking into distributed workflows, so that you can define a workflow that is partially at the edge where you do some pre-processing, maybe feature extraction for AI, and then you hand the results over to the cloud because there is not that much of a need of a bandwidth anymore to go and take the content from the edge then to the cloud. So I do the heavy lifting at the edge, and then the really difficult AI applications that might still run in the cloud. So we need to do something there. And well, edge and AI, as I said, it's kind of a match made in heaven. I have a model. I want to go and deploy the model at the edge. Maybe my node is too small to run that model. What do I do? Or, well, I have a model that I want to go and run on a Meraki camera, and it's too large for the Meraki camera. I need maybe an additional capacity, but I want to run a portion of the camera. So yeah, well, can you help me do this instead of I need to go and figure it out as a developer? Yes, let's go and focus on that one. So let's start with a bummer. I have two AI models. The first one requires 100 max, so that could be YOLO v5, unoptimized. And it doesn't really fit on my compute node. Might be a small one. If you look at what we have with Meraki cameras right now, they have a runtime, a TF Lite runtime that allows you to run custom models, but the maximum size of that model is 40 meg, which is large, but it's not super large. Second bummer is I can deploy it, but it only runs at 2 frames a second. And my use case is that I require 5 frames a second. What could that be? Well, one thing is people counting at a front door. So if you are running relatively slow, you might miss that these two gentlemen are overlapping. If you're running with relatively high frequency, then yeah, you might detect that you have 6 people really in the picture. So performance matters in certain cases. How can we fix that?
I want to jump in there real quick.
Absolutely.
So performance matters also not only from a frames perspective there, but also a lot of signage is also video delivery.
Oh yeah.
Right. So when you start doing video processing on an edge native node, you need much higher performance nodes. Yeah. So that would be an additional use case, right?
This is an additional use case, and this comes to the play where it can't be just one node. It might be either multiple nodes that then deliver on the capacity that you need, or you need a diversity of nodes. So a very small one and maybe one that is a little bit more capable for certain cases. So it can't be like the portfolio is this. You need to have a broader solution. So something might indeed cater for quick service restaurants. Something if you're running a superstore, then well you probably need, and you have more applications that you're running. And video compression at the edge, I think, or transcoding is another key use case. Like what comes in from the camera might be too high res for you to digest. Right. So it's like I have that myself. Like I have a little drone, and if I try to show it on this PC,
Thank you.
Slow. So performance matters. How can we deal with performance? One way is indeed to throw hardware at the problem. And I think that's what we've done with Meraki really well. So make the camera not a camera, but a mini computer with AI acceleration. Check. The second thing is what's typically, well, always or needs to be done if you run certain things at the edge is compression. Compression is all kinds of methods to reduce the complexity of the model so that it can run faster. Easy ones are you quantize, i.e. you go from floating point operations to integer operations, sometimes even int8, right? So make it really simple. And fusing operators, optimizing the graph, reducing the number of layers based on your learning or training data set, right? So you might not need all the layers because some of the layers do stuff that your use case doesn't require, because YOLO, for instance, is fairly complex. An additional thing that we started mucking around with, and that's Thomas Felton's work, a PhD student of mine that came up with that 2 years ago, said, well, how do we do what Cisco is really good at, distribution and splitting? We take an AI model and we partition it so that we can run one model across multiple nodes. Kind of straightforward, but not so straightforward if you do it in reality. Because if you split a model, first of all, you need to figure out where to split it so that it fits 2 nodes. And the splitting point is not only a capacity question between the 2 nodes, if I do this, but it's also a question of what's the bandwidth between the 2 gentlemen?
And the latency.
And the latency, right? This can be really costly. And we found that if it's less than a gig between the nodes, these layers communicate quite a bit. right? So these tensors that you need to go and shift across, this is heavy lifting. So there's real bandwidth involved. And so what we do today is we even run a qualification step, a calibration step of the network, of what the network is capable of doing before we do the splitting. Because upfront, you can't really just look at the CPU and nominal bandwidth capacity, and you'll see that you can figure it out, right? Because latency in that plays a role if you need to go and communicate backwards and forwards. Really good point. So what is feasible? If you run on a single node Onyx, and this is gentlemen's colleagues of mine floating into the Roller office in Switzerland, and we do object detection, including people detection. Single node, 1.1 frames a second. Two nodes with the same runtime, 1.7 frames a second. This is where you see the tax of splitting, because the nodes not only split and run AI, but they also communicate quite a bit. But if you have a node that is optimized to a different runtime, like the aforementioned Meraki camera, you run TF Lite, or it's optimized for TF Lite, then you can say, well, I have one model, and I convert one portion of the model automatically into TF Lite, and then run this portion on the optimized runtime that I have on a particular node, and then I can go even have further up. So there is potential to even distribute things. And the good thing is, historically, I had this trade-off between accuracy, so run a complex model, but that runs slow, frames a second is little. If I need to go faster, then I had to go and compromise on accuracy. If I can throw hardware at the problem, I can move to the right-hand side, higher frames a second, without compromising on accuracy. So it's a nice feature. So edge native is kind of cloud-like experience at the edge. Why do we do this? Yes, to solve these problems, but it catches a transition, what we found. Because if you look at these edges today, these smart service restaurants, or if you go to your favorite retail store today, you find a smart mirror, and the smart mirror is a shrink-wrap solution from one vendor. And then you have a solution for, say, loss prevention. So seeing whether people really scan the product at automatic self-checkout, or whether they scan bananas and they move a whiskey bottle. Another turnkey solution. And then you might have something for digital signage, or the customer wants another one for behavioral analytics of the customers in the store. It's all like point solutions built by one vendor that does this as a single trick pony. This works well for one, this works well for two, but you end up with a different management solution every time you do this, and like, it doesn't really work, right? So it calls for a platform approach. So this great bare platform that we've been talking about fits very nicely so that solution vendors can focus on building the solution. They don't need a vertically integrate the stack, and we can go and roll out solutions much faster. Right, so you start with one use case, maybe that's kind of fraud detection at automatic self-checkout, and then you can have behavioral analytics, you can count the people in your store, you can do, well, inventory management on your shelf list, and so forth. So it's really land and expand. And yeah, well, that's what we're trying to go and catch as a transition. So if you want to go and stay in touch, go and take a picture, subscribe. And if you want to read more about that, or kind of get a replay of the story, not with German English, but with your English, go to my blog that I've written on the plane when I came here.